All right, line T1, we're on learning task 1, and we are on a video B, because what we're going to be doing is expanding on what we started out in the first section, which was going to be just looking at what we had required for emergency lighting. Now we're going to go through a lot of the Canadian Electrical Code. Just bear with me for a second. Eli's being a total pain. He's sitting on my binder right now because he wants attention. Get off of there. All right. Let's go and take a look at our Canadian Electrical Code and how it relates into what we're looking at over here. We're going to start by going into our section 46. Section 46 is going to be emergency power supply, unit equipment, exit signs, and life safety systems. So it's comprised of 3 different sections that it is going to be covering. It is going to be applying to the installation, operation, maintenance of emergency power supply. So emergency power supply could be the battery packs that we're going to be talking about inside of the next learning task, the ones that we've looked at inside of our first learning task section here, or it could also be other types of emergency power supply, uninterruptible power supplies, generators, solar backups, anything that is going to be an emergency power supply that is different than our regular hybrid. Not a backup power supply for the sake of having one. We're not talking about when you get a power outage and you want to have a generator that's going to go and run your freezer or fridge. That's not considered to be emergency power. This is for life safety systems. It's for emergency power to life safety systems. So it could be to any of the ones that we're looking at right now, the unit equipment and the exit lighting. They could also be an emergency supply that applies to my fire alarm systems, or nurse call, or anything else like that. It also covers unit equipment, and then it does underneath B over here, it talks about that it's for the emergency supply and the unit equipment intended to provide illumination of exit signs in the event of the failure of a normal supply where emergency power supply is required by the National Building Code of Canada. And then section 2, or subrule 2, says the section applies to the wiring between the emergency power supply and the life safety systems that are required by the National Building Code of Canada. In other words, we're not going to find anything inside of our electrical code that tells us when we need to go and have lighting. We're just going to go and cover the electrical rules about how we install that emergency lighting. Okay, rolling down through here, same thing as usual. There's going to be a bunch of definitions that give us life safety systems, that it could be fire pumps, elevators, smoke venting fans, smoke control fans, dampers, anything like that that is going to be used in fire control for the most part. It's also going to be combined inside of here as a life safety system. All right, let's go and roll through a bunch of our general areas. There is a bunch of stuff that's inside of your binder. I'm not going to roll through it in the same order as it's inside of the binder over there. We're just going to go and deal with it in the order that's inside of the code book over here, and we'll just highlight those as we go through. First thing is these instructions over here. We'll start with this one. 46102, power supply equipment and unit equipment. So talking about those battery-powered lights that are going to go and come on to provide lighting for hallways, shall have adequate capacity and ratings to ensure satisfactory operation of all connected equipment when the principal source of power fails. Note that it's not the general to the whole building. It's talking about the principal source of power. So the area lighting in that zone is what we're actually going to attach these to, your unit equipment. Instructions, there has to be complete instructions. That instruction shall specify testing at least once every month. Every emergency equipment piece is supposed to be tested monthly. Maintenance, arrangement of lamps. 46106, emergency lamps shall be arranged. The failure of any one lamp will not leave in total darkness the area that would normally be illuminated by it. And no appliance or lamp, other than those required for emergency purposes, shall be supplied by the emergency circuits. You're not allowed to place other types of loads, just for fun, or because, somebody wants to keep their open sign going on the building or something like that. Refrigerators, anything that's not part of the emergency power has to be kept off of a emergency power system. They can go into a separate backup power system, we would call it, but they cannot be on the emergency power system. Okay, wiring methods. So, except as permitted by a couple of these sub-rules over here, the following. So, in other words, the generally cased, the following insulated conductors shall be installed in accordance with sub-rule 2. We need to go and have insulated conductors for life safety, for emergency power and exit signs, and between unit equipment and remote lamps. And all of these conductors described in sub-rule 1. So, in other words, unit equipment, emergency power, and life safety shall be installed in a metal raceway of the totally enclosed type. So EMT would be a metal raceway of the totally enclosed type, or shall be inside of a cable that has a metal arm or a sheath, or shall be inside of a rigid non-metallic conduit, so rigid PVC, anything like that, RTRC, etc. Has to have the name rigid inside of there. Or shall be installed in electrical non-metallic tubing, core line, where embedded in at least 50 millimeters, that's going to be at least 2 inches of poured concrete. So all of our emergency power and emergency lighting systems have to be protected, is really what they're telling us over here. Then it says, notwithstanding sub-rule number 2, if it is a building of combustible construction, so you got a wood frame, maybe small-scale commercial building, then you are allowed to go and have non-metallic sheath cable or non-metallic raceways. Sub-rule 4 states that the insulated conductors and cables installed in accordance with sub-rule 1, so emergency power and unit equipment, etc., shall be kept entirely independent of all other insulated conductors and equipment, and shall not enter a luminaire, raceway box, or unit equipment occupied by other insulated conductors except where necessary in either the transfer switch, where we're going to go and have the incoming, AC normal, and then the incoming AC, that's my emergency, if it's a generator one, or inside of an exit sign or emergency light that is supplied from 2 places. So going back into what we had over here, this situation that you see right over there, that would be the only time where they would be allowed to enter into the same box over here, as well as into the same fixture. Because in this case, it is an exit sign supplied by 2 different sources. Once again, this is the older style. You'll find this in older buildings, not in a lot of our newer ones, because in our newer ones, usually we just have a single ACN and individual batteries inside of every single exit one. It's just cheaper than running conduit and extra conductors absolutely everywhere. All right, let's roll back into that code there. Okay, insulated conductors and cables installed between an emergency power supply and any electrical equipment that is not defined as a life safety system, in accordance with the section, shall not enter a luminaire, raceway box, or cabinet occupied by conductors installed as described in sub-rule 1. So in other words, if you have got any sort of a conductor that comes from your emergency power supply, let's talk about a genset, and any electrical equipment that's not life safety, let's say the freezer, it is not allowed to go into the same luminaires, raceways, boxes, or cabinets, except where necessary in busway splitters and other similar enclosures provided for connection to the overcurrent device for emergency power supply. What this sub-rule talks about is that in some cases you're going to go and have a backup generator panel. And so you're going to have this generator that's going to be tied in with an automatic transfer switch. It'll come on when there's a power failure. When that thing comes on, it's going to power up the panel. And some of those circuits are going to be for your emergency and for your unit equipment. Others might be going to, fridges and freezers and stuff like that. That would be good to keep going, but are not deemed, the same necessity. That's the only place that they would be allowed inside of busway splitters and other similar enclosures, so panels, for connection to the overcurrent device. All right, emergency power supply. Note that these rules over here apply only to emergency power supply from central standby power sources. So these rules deal with when we've got a unit equipment piece, a piece of unit equipment lighting that has got a battery pack and we are feeding out of that to other stuff. These rules do not deal with standalone systems. If it's a box with a battery and a charger and a transfer and it's got lights but it doesn't go anywhere else, technically these ones don't go and apply to. We still use a lot of them inside of there, because it's best case, but this is really, really, really limited to places where I'm going to go and have distribution. Over here what they're showing, where you're going to have your AC supply coming in. That AC supply is then going to go into a battery, and then the battery goes out to the emergency lights, which could be located in a bunch of different places. This is pretty common. If you got to have 1 or 2 emergency lighting heads, you don't want to necessarily have to have a battery pack everywhere. So you have one larger battery pack, and you scab a whole pile of these smaller ones off of it. Okay, the emergency power supply shall be a standby supply consisting of either a storage battery of the rechargeable type or a generator. That's our two options for our type of emergency power supply. And if it is a battery, it has to be able to supply and maintain at 91% of full voltage the total load for the time period required by the National Building Code of Canada. In other words, there's going to be different time periods all the way up to 2 hours, depending upon the institution. But in no case less than 30 minutes. Highlight that section right over there. In no case less than 30 minutes. It has to be equipped with a charging means to maintain the battery in a charge condition automatically. We're not allowed to use automobile batteries. We're not allowed to use enclosed glass jar type of batteries. Those are rare. Nobody uses those anyways, but they put them in there because obviously somebody did and it caused a problem. That's how stuff gets written in the code book. There was an idiot out there that had glass jar batteries. That just sounds dangerous. When we have a generator, it shall be of sufficient capacity to carry the load, and it shall be arranged to start automatically without failure and without undue delay upon the failure of the normal power supply to any transfer switch connected to the generator. Some cases we will have only a central generator and we'll have smaller distributed transfer switches that are going to be going throughout the building. If for whatever reason, let's say that I'm going off of a floors type of idea, we'll just draw that in over there. I'm going to have a central genset over here, and that genset might be going up to multiple different floors. And each of those different floors is going to go and have a transfer switch. Okay, I'm just going to draw in 2 transfer switches. Well, we'll draw in 3. So here's my generator. It's going to go and feed into this pole of all of these transfer switches. I'm drawing it as a one-line diagram here, but I think you're all sufficiently, capable of understanding that. Here's my BC Hydro. BC Hydro is going to go into the other side of all of these transfer switches. And then these transfer switches are all going to be automatically connected over to the BC Hydro side. And from there, they go out to their individual loads on each of these individual floors. So normally we see that we would be feeding in from BC Hydro through the transfer switch and over to our individual loads. If, however, that one of these floors were to go and lose connection, let's say this one over here were to lose its incoming BC Hydro, maybe it was just a fusible disconnect that blew or something like that, what should happen then is this transfer switch will kick over, and even though all the floors aren't calling for it, the fact that any single one of them is calling for it should go and start up, energize our genset, which would then be able to go and deliver power out to that floor over there. So upon the failure, it has to start automatically upon the failure of normal power supply to any transfer switch that is connected to the generator, and then it has to be in conformance with the CSA standards. We'll skip past all of that there. That's protection standard. It has to be protected against fire exposure, so use your fire seal, etc. Control, emergency power supply shall be controlled by automatic transfer equipment, whether inside of the unit equipment, so what we saw inside of these ones over here, where we've got that little battery and trickle charger, and then we've got that contactor that's going to go and fire in, or it could be off of a larger system, like an actual transfer switch for a genset. Emergency power supply shall be controlled by automatic transfer equipment that actuates the emergency power supply upon failure of the normal current supply and that is accessible only to authorized persons. It shouldn't be anywhere in the public that they can go and use. This one over here was a change in our latest code. It said an automatic light actuated device shall be permitted to control separately the lights located in an area that is adequately illuminated during daylight hours without the need for artificial lighting. It's a new set of rules, and what they're doing with this set of rules is they're saying if we have got a photocell, let's say we got a big atrium, loads of light coming in, we don't want to necessarily run off of our battery because it's going to draw down the battery. We don't know how long the power failure is going to last. So as long as we got exterior light coming in at sufficiently high levels, we'll just operate this photocell that's going to go and keep those lights shut off. That's what they're talking about inside of here. Okay, overcurrent protection, these ones just state that it has to be rated and that it shall be accessible to only authorized persons. This one over here, every emergency power supply, so unit equipment, whether it's going to be the unit equipment mounted on the walls or whether it is going to be a genset, shall be equipped with audible and visual trouble signal devices that warn of derangement of the current sources. Derangement just means different arrangement. So in other words, if my AC fails and my emergency comes on, and that indicate when these are supplied by the emergency power supply. Usually we are going to go see those as those little LEDs that are going to be on the sides of the pieces of unit equipment. I don't know if they show. Yeah, they show one over here. A couple of LEDs off for on or for charge. Charge would indicate that there's AC to it and that it's charging the batteries. On would go to indicate that this thing has lost the AC and that the batteries are turned on. Then we got a test switch on that one as well. Audible trouble signals shall be permitted to be connected, so you're allowed to have horns and buzzers and stuff, but they can be silenced, but you can never get rid of the red warning light. And whenever a system is restored to normal, the audible signal will sound once again, indicating the need to restore the silencing system to its normal position. So if you've got a silencing switch, that silencing switch is going to go and stay beeping until you go and put it back to its regular one. Or it can just go and reset automatically. Remote lamps, this is going to be individual heads, shall be permitted to be mounted at some distance from the current supply that feeds them, but the voltage drop shall not exceed 5% of the applied value of voltage that we are going to go and have. All right, talking about the unit equipment now. This is going to be unit equipment for emergency lighting only, so specific to. Some of our unit equipment falls in these previous rules, the 46, 200 to 212. Now we're going to be talking about ones that are specifically to unit equipment. If we've got the unit equipment, that's the little battery backups not coming off of the central generator. Okay, each unit equipment shall be mounted to the bottom of the enclosure, not less than 2 meters. Highlight this section over here. Not less than 2 meters above the floor. That's how low the actual unit equipment has to go and be. Receptacles to which unit equipment is to be connected shall be not less than 2.5 meters. We mount those things high. Standard appliance cord length is 2 meters. That's vacuum cleaners and the like. Which means that if we put something 2.5 meters, most people won't go plug day-to-day equipment into it. We don't want them running day-to-day equipment on it because they might trip out the breaker, etc. So it has to be not less than 2.5 meters above the floor and not more than 1.5 meters from the location of our actual unit equipment. Looking at something like this over here, that would mean if my receptacle is going to be over here, from here to the ground, 2.5 meters, and from here to the unit equipment, no more than 1.5 meters, just for that cord length itself. Usually we try to keep them about a foot away or something like that. Once you know where these things are, they're relatively easy to go in place. Unit equipment has to be permanently connected or hardwired in to the supply if it exceeds 250 volts or if it exceeds 24 amps, so either lots of current or higher values of voltage. And then it says where the ratings in subrule 2 are not exceeded, where it's below that 250 volts and the 24 amps, the unit equipment shall be permitted to be connected using the flexible cord and attachment plug supplied with the equipment. Note that it says supplied with the equipment. You're not allowed to just grab a piece of unit equipment, scab on your own cab tire and a big old yellow cord end onto there. If it is not rated by the manufacturer and come as part of the equipment, we cannot go and use it. And then unit equipment shall be installed in such a manner that it will be automatically actuated upon the failure of the power supply to the normal lighting in the area covered by that unit equipment. Going back to this over here, this receptacle over here would be coming off of whatever I've got for my regular lighting in that section. Not off of the switch, because then every time the switch goes off, the unit equipment comes on, but off of the actual power circuit, the full, line and neutral coming into there. So we'll splice that in, take that receptacle off, drop it down to my unit equipment over here, and then that way if I lose the circuit that feeds all of these lights over here for whatever reason, my unit equipment comes on. Okay, size of insulated circuit conductors to remote lamps shall be such that the voltage drop does not exceed 5% of the marked output voltage of the unit equipment. So if it's a 12 volt unit, we can't be below 95%, or other such voltage drop for which the performance of the unit equipment is certified when connected to the specific remote lamp being installed. This is really big on LEDs. On our old incandescents, those halogens, they were big and bright and took a lot of juice. Now with all of our LEDs, we can go and connect these things in a lot of cases, in a manner that we're going to have sometimes like a 20 or 40% voltage drop, and they're still going to be fine because most of those are dropping it down anyways inside of there. You remember that zener that we took a look at when we were dealing with rectification, where we chopped off the top of the waveform? In a lot of cases, the actual LEDs are going to be like 3 or 5 volts for the LED system itself, which means that a 12 volt conductor coming in, they're discarding 9 volts of it at these units. So if it comes in, as long as it comes in above that 3 to 5 volts, it's going to be fine. But once again, follow the manufacturer specs on it. Remote lamps shall be suitable and shall be included in the list of lamps provided with the unit equipment. We're not allowed to just grab any lamps and stick them on there. We have to go with what the manufacturer has specified in their documentation. No mixing and matching. They're not going to specify anybody other than their own inside there because obviously they're looking to maintain their market share as well. And then the number of lamps connected shall not exceed a load in excess of the watts output rating, and the load shall be computed from the information in the list of lamps referred to in subrule 2. Once again, add up all the watts, make sure you're not over top. We talked about that before. All right, 46400, exit lighting signs. Exit signs, where exit signs are connected to an electrical circuit, that circuit shall be used for no other purpose. So I can have one circuit that is going to go all around my building. That's just going to pick up all the exit signs on that. But I don't need to, because subrule 2 of it says, notwithstanding subrule 1, exit signs shall be permitted to be connected to a circuit supplying emergency lighting in the area where the exit signs are installed. So going back into what we had over here, here was my unit equipment receptacle mounted 2.5 meters above the floor. Here's my unit equipment itself that was going to go and plug in. I took this off of the incoming 120 volt that was coming from here. It turns out that I would also be allowed to go and take off my exit sign itself from that same circuit because that circuit is supplying the emergency lighting in that area. Okay, exit signs referred to subrules 1 and 2 shall be illuminated by an emergency power supply where emergency lighting is required by the National Building Code of Canada. So exit signs do not need to be self-illuminated unless they're inside of a building that requires illumination. Now, you're never going to find anything that's not, well, I shouldn't say never, it's rare that you're going to find anything that's not, but this means that not every single one of them will actually require that. And then subrule 4, the circuitry serving luminaires used to illuminate exit signs that are not connected to any electrical circuits. So you should have this, exit signs that are not connected. These are photoluminescent ones. Shall comply with subrules 1 to 3 as required by the National Building Code of Canada. So this subrule 4 over here is dealing with the glow-in-the-dark ones. And the glow-in-the-dark ones, what we are allowed to do is we are allowed to take the light that is going to be closest to it, the one that is bathing that exit sign, so it's glow-in-the-dark one, no electrical. The one that bathes it inside a light, first of all, it has to be unswitched, so it's always going to go and be on. And we're allowed to take it from the regular lighting in that area, or I could connect it to a standalone exit lighting circuit going through the rest of the building. All right, anything that I'm missing? Let me just quickly blitz over and take a look what the binder has in there. I don't think that there's anything inside of here that we are much worried about. Yeah, everything inside of there we've covered inside of this. We went through that whole section. It's not a huge section, but it's a really important section. Big things for you to go and keep straight are just going to be the difference between unit equipment, emergency power supplies, and then exit lighting. 3 separate things. Unit equipment is always going to go and have batteries, lights, and an AC supply. Emergency power supply could be a generator or it could be a big battery system that could supply other stuff as well. You know, the fire safety stuff in particular. And then exit signs are just going to go and be the ones that illuminate above the exit so we can find those in case of emergency. All right, that's the end of this one.